All right. So I am here with Toby from Tobiko Data or Data. How do you say it?
Tobiko data.
Tobiko Data. Okay, awesome. Uh, you want to tell me a little bit about what your team does?
Sure. So I'm the CTO and one of the three co-founders of Tobiko Data. We work on open core products such as SQLMesh and SQLplot. Our flagship product, SQLMesh, is a data transformation framework, and it basically takes the best of what our founding team learned at companies like Netflix and Airbnb and made them open source.
What in first, I think a few questions. In a nutshell, what does the tool really do?
Okay. So companies process data, right? Through transformations. Basically, there's like a lot of raw data. You might ingest it somehow, and then at the end of the day, you want a report. But it's very hard to make a report off of raw data, right? And so generally, data teams write a bunch of SQL queries or Python code to basically transform the raw data into some form that's more easily consumable by dashboarding tools. And so SQLMesh is a Python framework that enables you to write SQL code or Python, and there's a lot of nice things that it helps you with, right? It automatically infers dependencies, so you can just write SQL queries and it'll automatically execute things in the right order. You don't have to tell it, with special commands like refs, like how to do things. It just works because we can parse SQL. It handles incrementality, right? Basically, we keep track of state, so we understand versions of models. We understand when models should run, and we understand when they did run, right? And so it's a full-blown scheduler as well. And
Awesome.
so with SQLMesh, data teams at any scale company can basically be very productive, ensure that they're producing high quality, high performance, and well-tested data pipelines.
Got it. Now I hear a lot of in terms of the ease of building from an efficiency standpoint, and for the sake of this efficiency, meaning from a cost effectiveness standpoint,
Mm.
is there logic behind the scenes to make sure that everything is as cost efficient as possible, or is it just blindly, hey, it all just depends on how you write it and just throw it out there and full replace tables every time?
Yeah, that's a great question. So there's a couple of factors of efficiency. So the very first kind of step, the first thing that happens is SQLMesh has a compile step, right? And it basically converts all of your code and macros and can parse them, right? Because it's built off of SQLcloud, which is our open source SQL parser. And so what that does is that it catches any syntax errors that you have before you even send them to the warehouse. So for example, if you're missing a parentheses or calling something with the wrong arguments, it'll say, hey, there's a syntax error here. Let's fix that first. And other tools on the market they don't understand SQL, right? So they'll just blindly send the SQL up to the warehouse, compute some of the things, and then when it gets to the model with the syntax error out, and you lose all your progress, right? So that's step one of efficiency, basically making it so that you're not wasting as much time. Number two is state, right? Because SQLMesh has state as a first-class citizen, it remembers what you've done and where you've left off. And so let's say there's a case where we didn't catch properly, or we didn't have full type annotations, and so we didn't know that you messed up the type, right? Well, let's say you ran 5 models successfully and the 6th model errored out, right? With SQLMesh, we know that those 5 models were successful, and you only need to rerun the 6th model. That's all automatic. Whereas with other tools on the market, there's no state, right? And so you'd have to basically blindly refresh everything.
Yep.
The last kind of aspect of efficiency is our concept of virtual data environments. So basically, with SQLMesh, we have an abstraction where we have a physical layer and a virtual layer. So in the physical layer, that's where we store all the actual materializations. So basically, it's like a hash table, and basically, if it's a table, it's a table, it's a view, it's a view, it goes there, right? But it's kind of like not really for users, it's kind of an internally managed system. And then on top of that, we have views, right? So the views make up your actual production or development environments, and they just point to the correct physical table. And so what that means is when I create a development environment, instead of having to like refresh my entire warehouse to create a target dev environment with a full copy of everything, I can just create views pointing to the exact same tables, underlying tables that production is, right? So it's an instantaneous and representative development environment, right? And then so now when I make changes, right, I just switch out the physical tables that need to be switched and then swap the views. And then finally, when I'm ready to promote it to production, instead of again rerunning everything, right, like other tools do, right, SQLMesh can just switch the view pointers from production to the work I've already done, right? So there's a lot of stuff under the hood to make sure that SQLMesh only computes what is necessary.
Got it. Would you say that it is a tool suitable for, I guess, it's a two-part question. One is this a tool that really you see the benefit primarily at like large enterprise type organizations? Or is this a tool that you would consider, hey, a very small team of like 1, 2, 3 people would find this helpful? Or would it be like, what would be the trade-off in there between from the enterprise versus small team in terms of the applicability of the tool?
Yeah, in general, we target the middle-sized companies, but we have success and we have customers from 1 to 2 people data teams all the way to large enterprises with 10 orgs of data teams working on various projects, right? And so we've seen success from both ends of the spectrum. I would say from their very small teams perspective, they love SQLMesh because of how simple and intuitive it is to be. You just write SQL. You don't have to worry about Ginger or anything like that. You just write SQL and it just works. You don't have to do different targets or anything like that. You just have a dev environment. You can promote to prod. Very simple, very easy, simply SQL, right? For the larger organizations, they love that we have an open source CI/CD bot. They love breaking non-breaking changes. They love the efficiency, right? And so depending on your organization, the scale and the size, there's different things to love about SQLMesh.
Got it. So with that said too, what is the skill level that you would say is needed in terms of SQL? Let's just pick SQL just for now. What's like the level of SQL someone would need to know to really get started with SQLMesh?
I would say in order to be successful with SQLMesh, you should definitely know SQL. You should be comfortable writing SQL queries that can be chained together. So like a sequence, or perhaps you can call it a pipeline of SQL queries. Once you have that, you have basically everything you need to be successful with SQLMesh. Now, we do have some teams too that only use Python, right? They only use Pandas operations or PySpark, so they're successful as well. But I would say that we are not a point-and-click tool. We're not like a GUI low-code tool. You definitely either need to know SQL or Python.
When you think as to where you are now in terms of the capabilities that it has, and in terms of where you want to be in the future, what does the future look like versus where you are now? And obviously, I know there's some competitive advantage you may not want to give out, but generally speaking, what are some of the areas that this is where our tool could use some improvement right now? And this is how we want to make it better, and some additional thought that you are like, hey, I actually want to implement this as well too.
So in the grand scheme of things, we're still relatively new. We've been around about 2 years, but we've made a lot of progress and we've grown our community quite significantly. And we have, I think, over, as of right now, 3,600 people in our Slack community. And I'm quite pleased with how it's gone so far. I've been having a lot of fun building out the company and seeing kind of people use and get value out of the tool. Now, in terms of kind of where we want to be, right now we have a big focus at the company on our cloud platform, right? Basically extending SQLMesh's core capabilities into something that's going to be even better, right? Basically something that enterprises running SQLMesh at scale will really want to use. One of the areas that I'm really passionate about these days is like security and data privacy. And so basically combining role-based access control with our virtual data environments, I think there's a lot of potential there for for how we can kind of change both how safe it is to develop data as well as keeping people productive, right? You definitely want to respect all data privacy laws, etc., and have good data hygiene, but you also want your teams to be productive, right? And so that's a tricky balance, and I believe that we are well suited and we have the architecture to support that kind of future.
When you see folks trying to implement the tool, what are some of the common aha moments that you hear them share, as well as what are some of the difficulties that some folks sometimes experience when onboarding the tool, that people should perhaps be prepared when trying it out, and should they encounter certain hiccups?
Just today, I was talking to my solutions architect, and they were telling me when they made a change, so they had two models, A and B. A feeds into B, and B was a select star from A query. And so basically, they added a column to A. And SQLMesh said, hey, you made a change to A, and that was expected. But then it said, hey, you made a change to B. And at first, my solutions architect was confused. He's like, hey, why is this doing that? Why, that's unexpected. I'm like, no, that's exactly what you want. You added a column to A and you just select star from B. And so you unknowingly broke B, right? You broke what B is because you did a select star. And SQLMesh, instead of letting you just do that, warned you about it and said, hey, you made a breaking change to B. Is that really what you wanted to do? And then he was like, oh, wow, that is the aha moment. It's like SQLMesh, caught something that he didn't catch, right?
And this is before it even executed anything.
That's right.
So technically, you hadn't hit the where. So hypothetically speaking, you have a model that has 10 terabytes worth of data. You made a change, and then potentially you ruin the whole data set.
Exactly.
This right here is saying, hey, watch out. This is what's going to happen. Are you okay with that?
That's
and
exactly right.
The flip side to that, I'd assume, is if it had been a select star, but you were just picking the right columns, it wouldn't have mattered likely. Or I guess, how would it have mattered if it had actually perhaps made the data set more granular, perhaps? I'm curious.
So if he had done a where filter on model A, we would have caught that as well. We would have said, hey, you changed A and you made a breaking change to B, right? So it would, I can show you a demo later demonstrating these exact use cases and then how it catched that.
No, that's pretty cool.
And to answer your second question, it's like, where kind of has it been more difficult for users, right? I think that especially if you come from a DBT world, we do things very differently. And so some of like the DBT patterns that people are used to don't translate exactly to SQLMesh, or perhaps we do things differently. As an example, just today, right? Someone came into our channel and was trying to set up multiple gateways, or in DBT it's called targets. And they were having a little bit of difficulty figuring that out. And I said, well, why do you want multiple targets? Did you know that SQLMesh has dev environments within production? It's much easier. You'll only need one target, but then you can have dev environments. And so they didn't realize that because the design patterns that we have are a little bit different. And so I think that especially for those kind of users who are transitioning, there can be a little bit of a learning curve because the way we've done things is a little bit different.
Got it. Before, I don't want to dive too much into DBT. I know there's a little bit of a back and forth in there, but that's fun. But I'm going to ask you a question that probably is not very often asked in interviews, and that is, what are two things that you actually admire from DBT?
Well, first and foremost, DBT is kind of a pioneer in this space, right? Really evangelizing, code first data pipelines, right? And making, for example, code, Git repositories, etc., kind of a thing, right? And so they are definitely innovative pioneers in this space and deserve a lot of credit for that, right? Additionally, their massive community, right, and following is is amazing. It's incredible what they've done. In fact, they've even grown a new job title, the analytics engineer. And so, of course, I admire them. And um, everything that they've done is something that kind of I respect and do my best to try to follow in their footsteps. Obviously, trying to learn from mistakes as well.
Yeah, so it's not so much like, oh, DBT is the worst thing ever, but it's more like, hey, DBT has done a great job with here, but based on what we've learned and additional things that have happened, we believe we have a product that really is a good replacement to DBT for XYZ reason.
Yeah, of course. DBT is a fantastic tool, right, for the right group of people and for the right projects. And it's a lot older than our tool, right? It was created, I don't know, maybe 8-9 years ago, and so at that time there weren't the same technologies that there are today that can enable some of the things SQLMesh can do. So naturally, SQLMesh can do a little bit more, right? And so, I mean, maybe you've seen some of the banter on social media, but it's just that, right? It's just kind of banter and marketing.
One more question before we dive into demo. What platforms is it compatible with?
It's compatible with most of the major warehouses. Of course, BigQuery, Databricks, Snowflake, Redshift, Athena, Trino, Spark, Postgres, MySQL, T-SQL, SQL Server, right? Lots of stuff. DuckDB, Mother Duck.
Do you spend a lot of time, I would assume, working on making sure that the translations that are being done in the back is basically supporting like the best capabilities that each platform supports? Because every platform can do things a few different ways.
Yeah, sure. I mean, we do our best there, and we spend the majority of our time on the more popular warehouses, of course. But we are open source, and so any issues or ideas that people in the community may have, they're free to kind of submit issues or PRs. All right. So this is our open source UI. You can do some light code editing, and additionally, you can do things like view column level lineage and do plans it applies. So the first thing we'll see here is a model definition in SQLMesh. If you're familiar with DBT, it looks a little bit different. You can see here that our format is a little bit more SQL native, right? It looks just like SQL. There's no Jinja, there's no ref. And that's because SQLMesh can automatically parse the SQL and understand the dependencies directly. So you can see here that you even get column level lineage out of the box for free, right?
And this is before execution, correct?
That's right. This is purely through static analysis by looking at the code. So for example, if you wanted to know what order amount was, you can see that order amount is the product of the item price times the quantity, right? And that's all done with static analysis. So I've already created a production environment, and if you want to query this table, you can. So if we just do select db item d, you can see that we have some data in here. Okay.
How do I know what connection this is connected to?
That's done through the config, and you can see that it's just doing the DuckDB right now.
Okay, got it. Okay.
So the first thing someone wants to do when they're doing transformation is make a change, right? So I'm going to create a dev environment. So I can just add a dev environment right here, and I'm going to do plan. So SQLMesh has a concept of plan apply. It lets you kind of see your changes before you do them. In this particular case, I'm just making a copy of prod, and so it just calls it a virtual update, right? I'm not making any changes. I just want my dev environment to mimic prod. And you saw how fast and instantaneous that was. That's because it's not doing any real work. It's just creating views, right, in my dev environment that will point to my prod physical data. So you can see here that I can now namespace my my schema with dev to get the exact same view. Okay. All right, let's do something more interesting. Let's add a column here. So let's say I do something like round item price to 2 decimal places as rounded. Okay. I'm going to save that, and you can see instantly, we get some automatic formatting, etc. So I'm going to run plan here. So now it's more interesting. Now it says, hey, you made a non-breaking change to item D, and downstream of it, you have modified indirectly these 2 tables. I can look here and I can say, oh, okay, I did indeed add a new column. Now, SQLMesh is smart enough to understand that this is a non-breaking change. And the reason why it's a non-breaking change is all I've done is add a column, and these two downstream tables, they don't use that column, so it's completely safe. And so you can see here that SQLMesh knows that all I need to do is backfill item D. I do not need to touch the downstream tables. Does that make sense?
Yes. Does it keep track of dependencies outside of the warehouse itself? Or, for example, let's say you have a Power BI or a Sigma report that connects to a table. Does it keep track of that part?
So it keeps track of right now all the upstream dependencies, so with external models. So you can define a YAML file with schema of stuff that's outside, right?
Got it.
But in terms of downstream, we don't have that quite yet.
Do you have integrations along those lines with tools like Cube or at scale in terms of what they're
Cube has actually integrated SQLMesh. So Cube is using SQLMesh internally.
Okay.
And they've also created kind of like an AI integration between SQLMesh tables and Cube semantics layer. So that's they've played around with that.
Nifty. Huh.
Yeah. Cool. So now I'm going to query my new my table, right? So you can see here that in my dev table, I have this new column called rounded, right? But you can see here it didn't touch my prod table. If I remove this prefix here, you can see my prod table remains untouched. So I've been able to easily create, this new table without touching prod.
Yeah. While you're developing this model and figure out if it's what you want long term or not.
Exactly. Yeah. So let's do something even more interesting. Let's modify a column here, and maybe let's do where rounded is greater than $3. Okay. Saved it. Did some auto formatting there. I went around plan. Now, SQLMesh says, hey, you made a breaking change, right? And it's a breaking change because I've modified a column, right? And I've changed the cardinality, which means that these downstream tables may be affected. And so now you can see that it says, hey, you need to backfill these 3 tables, not just one. So I'll go ahead and run that. And so it's going to do the work now to process all that data.
Pretty sweet.
Yep. Let's wait for that to finish. All right. So now when I query the dev table, you can see indeed, let's see here, that my item price has changed, right? And if you really want to know the difference, SQLMesh comes with an automatic data diffing tool. And so if I just go here, I can say, hey, I want to see how this table is different from my production table. So I just press this button, get there. And you can see immediately that it's like, okay, well, your new table has a new column rounded, right? And also on the item price table, you can see that all the numbers are different, right? Because I multiply them by 0.99. And then finally, you can see that let's see, probably don't have the next page, but this is a really quick way to see the difference between what you've done and what you have in production.
It's pretty nifty. Pretty nifty.
And then one more thing I want to show with the dev flow is like, okay, this all looks good. I like it. I'm ready to go to production. So I'm just going to click prod here, and I'm going to click plan. And again, it's going to say, hey, compared to production, you've made a breaking change, right? Compared to production, these are all the things that you've done differently. And the thing here, though, is now it's an apply virtual update. But if you use DBT or other tools, you might be like, hey, why don't I have to rerun this again? Usually when I use DBT and I want to merge to main and run it in production, I got to rerun it. Well, with SQLMesh, because of virtual data environments, you've already done the work, right? And so we can just switch the pointers of production to the tables that I've actually just done. And so it's instantaneous, right? It's like a true data deployment. And
which would that translate to speed, cost savings? What does that mean to the end users?
Yeah, exactly. You're saving money because you're not rerunning it. You're saving time because it's instantaneous. And I've been able to validate the exact date table that I've tested to production, not just the code, right? So with like other tools, right? you're only shipping the code. But when you ship the code, you have to rerun it again, right? And that data might have changed. With SQLMesh, you're not just shipping code, you're also shipping data.
It's pretty nifty.
And just to prove that this works, I can go here now, I query my prod table, and you can see that I now have the new data reflected.
Got it. You're just like, hey, why do the compute 2 times? I've already done the compute on this. Might as well do it. Yeah.
Exactly. And then it also means you can do things like automatic rollbacks, right? So if I just rolled back, I could also just swap it instantaneously. I don't have to redo a computation for rolling back.
Now, where's that data residing temporarily?
So SQLMesh has state natively, right? And so by default, we store all of the metadata in the warehouse that you do your computation. But because warehouses in general are not great for OLTP, workloads, we recommend you using Postgres for that, or our cloud offering, which is stored Postgres as well.
Got it. Okay.
So additionally, like the UI has
what God. So there is a potential cost implication there. It's just not. It's not necessarily as compute heavy as it's much more of a storage heavy implication.
Sure, whatever the cost of storing, a small Postgres database is.
Yeah, but if you're doing this at, say, at the scale of terabytes, though,
right?
Yeah, and then you're talking about the reads, the writes, and some of that, some of those transfer related fees.
Well, hold on. So only the metadata is stored in Postgres.
Oh, got it. Okay, got it.
Only the data processing.
Okay, that's what I thought. At first, I was like, wait a second. Okay, that makes a lot more sense.
No worries. But we actually just did launch a feature. We posted a blog post about called multi-gateway support. And so what that means is that with one project, you can choose which engine you want to do the processing. And so, for example, if I want to use Postgres on one model, but then I want to use DuckDB on another model, you could do that as well.
Got it.
All right. And then one more thing I can show is we have real Python models. So you can just write Python code here, and you can do anything you want. You can, run SQL queries. You can make API requests. As long as you return a Python data frame or a PySpark or Snowpark data frame, it all integrates into the same system.
That's pretty sweet.
All right. Yeah, that's it.
Awesome. Well, another question that I have, and thank you for that.
Sure.
Are you familiar with, for example, Delta Life tables?
Yes, I am.
Where would you say there's competition with like Delta Life tables? I believe Snowflake's equivalent is dynamic tables, I think, too. Where would you say here there's competition in this regard, and this is how we differ from those offerings?
So in terms of those kind of materializations, so Snowflake's dynamic tables, we have an integration with that in SQLMesh. So you can create a model in SQLMesh with a dynamic table, and so it will integrate, with Snowflake, etc.
Got it.
We haven't done the same thing with Delta Live tables because it's a little tricky because, they kind of operate on notebooks, and you have to spit it up and maybe it's submit a notebook, something like that. I don't quite remember the details, but it was a little bit trickier. If they made that API a little bit easier, then we would integrate there.
Got it. Okay.
But I would say there's not too much competition. Those things are great and they're real-time systems, but they're kind of more low level, right? And so you can certainly use those systems to ingest data or whatnot. But then you would use SQLMesh to kind of orchestrate things, manage changes, and all those kind of things.
That's fair. I appreciate it. Any other last words you want to share?
No, thanks for having me here. And, if you're listening and you're interested in kind of joining us in our community, we have a growing Slack channel at tobikodata.com/Slack.
Awesome. Thank you so very much, man. I appreciate it.
No, thanks for having me.